again, switching significantly now in topics. They're obviously all interrelated for the development of virtual reality systems. I want to talk about tracking systems. In other words, systems designed for tracking, or estimation if you like, of the motions that are occurring in the physical world that need to be somehow brought into or taken into account in the virtual world. So what do we want to track? Or what do we need to track? Some things are optional, some things seem absolutely necessary. Remember our rigid bodies we talked about, and we talked about transformations of rigid bodies. So we're going to be estimating some transformation that corresponds to how much translation and rotation has occurred in some body of interest since the beginning. So we think about rigid bodies. The number one case that we care about is the head that is wearing the head mounted display. Need to track that. Even in a cave like virtual reality system where you have projection screens all around, if you want to change the perspective and provide stereo to the user, then you have to track their head in that scenario as well. So even beyond head mounted displays, you may still need to do head tracking in this case. So this is very important because it provides the correct viewpoint. That is the part that's most sensitive, I would say, to get right, because that's what's going to your retina ultimately, and small imperfections in that, as we've been saying, can cause great discomfort or disbelief, like maybe it won't even look right at all. So that one's very critical. 2, we may be able to do even better by tracking your eyes. We could figure out then which way your fovea is pointed and provide higher quality images there and not worry about the rest. It'd be like some kind of automatic compression that's built into your graphical rendering system. That'd be wonderful if you can track accurately enough and with low enough latency, low enough delays, then that would be great. 3, perhaps we want to track the palms of your hands. Right, maybe you're grabbing onto controllers and you want to move around. Track your hands through space. If you're off by a little bit, it's probably not going to be nauseating. If you're off by a little bit for head tracking, it could be very nauseating. So it's a different scenario. How much do you need? Are you trying to do telesurgery through a virtual reality interface? Then accurate hand tracking could be critical. If you're just trying to make some gestures to your friends, maybe it's not very critical, right? It depends on what you're trying to do. You have to think very carefully about the tasks here. Number one, it's critical to be very accurate here and have low latency. But for the other ones, even for eyes, if you're not doing foveated rendering, but maybe you just want to keep track roughly of where people are looking for some kind of social interaction in VR. Just some coarse tracking with significant amount of latency might not cause much trouble, just if you want to know where people are looking in VR. That may be fine. So as you go down, you know, the performance requirements may vary significantly depending on your task. Maybe I want to track your fingers very precisely. Maybe we'll just add in the entire body. Maybe there are movable objects. For example, I might have a coffee mug in the physical world. I might want to keep track of that, where it's at, so that I can perceive it in the virtual world. I might even want to reproduce my desk if I'm sitting at a desk in the virtual world so that I know whether or not I'm knocking my virtual coffee cup off of the virtual desk, because that will correspond to knocking it off of the real desk in the real world. So maybe I want to bring some objects that are around me from the physical world into the virtual world. How do I do that? Do I want to put special barcodes or some kind of easily identifiable markers on them, QR tags and things like that on my objects? Do I want to use pure computer vision techniques to try to bring them in, hopefully in a reliable way, into my virtual world? So, so keeping track of movable objects that are around me might become important. And finally, other people in the space. People, maybe pets, could be anything that you have that's moving around autonomously that you want to keep track of. Could even be your vacuum cleaning robot. It doesn't matter to me, but there are other things you might want to track, and that may become relevant to your VR system. It could be the other people you're tracking are in fact in a shared virtual reality space with you, and they'll collide in the real world in addition to the virtual world, so you need to keep track of them as well. So there needs to be information shared for a system like that. All right, so that gives you a bunch of different possible bodies to track, and sometimes these bodies are all attached together, like the head and the eyes and palms of your hands and your fingers. Your whole body's attached together. There are kinematic models you can make and utilize to improve tracking methods. So something to think about. It's not necessarily just a bunch of detached rigid bodies. Now for each rigid body, we want to estimate the rotation plus translation. Right. Probably shouldn't say plus, I probably should just say and. Don't want to make it look like I'm doing some bad mathematical operation. All right. Well, remember that for rotation we had a rotation matrix R 3 by 3, or we used Quaternions, which we hopefully agreed on was perhaps the best representation to be using. And for translation, so that's rotation. And for translation we used a 3D vector xt, yt, zt. Which, using our homogeneous matrix representation, we had 3 by 3 matrix and then xt, yt, zt, and finally completing the 4 by 4 matrix like that. So we're trying to estimate a matrix of that form over time, and the initial conditions sometimes end up being important. Like for example, as soon as we start up the tracking system, you put on a headset, which way are you looking? This often ends up being difficult. If there's no camera, suppose you just have a perfectly portable system with no wires attached to it at all. When I start up the tracking system, is the direction you're looking the direction that you want to call the identity? Or maybe you just have it sitting on the table lying in some strange orientation, and you put it on your head and you're like, oh no, why do I have to turn my head around to face the front? Right, so there's always a startup condition here that's a little bit complex, I guess. If you have some fixed reference point like a camera that you've set up and you want to say, okay, the starting identity transformation is going to be 1 meter in front of the camera facing the camera, then you can figure out all transformations relative to that. If you do not have a fixed global reference, then sometimes you have to just assume the user is careful when they start up the program, or you may want to give them a reset key so they can reset their position and orientation based on where they're looking at right now, based on where the head's positioned right now. Does that make sense? There's always this initial condition problem, and as you've tried different applications in VR, you may have experienced some of these kinds of frustrations with the startup conditions and things.